Hi, I'm Bob Tabor with LearnVisualStudio.net. In the previous lesson, we wrote a bunch of JavaScript code. Hopefully it wasn't too complex. Hopefully you were able to figure out what it was going to do before we even attempted to run the application. Hopefully you were able to make it actually function the way that I did in the video. Hopefully, if it didn't work out the way originally that you typed it in, you were able to narrow down the problems using the F12 developer tools or just combing through the code and comparing what I did versus what you did. Solving your own problems is a huge part of being a software developer, and sometimes you just have to have that attention to detail and really ferret out the problems that might exist in your code. But nonetheless, I didn't even attempt to explain the code I was trying to write, maybe just made some passing references. But what I want to do in this lesson is to make sure to explain at a high level what's going on in these applications, and then we'll spend the next 7 or 8 lessons speaking about each of the individual JavaScript syntax elements and concepts that we introduced in this video. Alright, so let's go ahead and get started. First of all, in our very first video, we simply added our JavaScript using the onLoad attribute of the body tag. That was one way to write JavaScript code in line inside an HTML attribute. The second way we demonstrated in the second video was to create an opening and closing script tag, and I put those in the head section of our document. Inside there, we were able to write a function. We'll talk about that in just a moment. But the JavaScript code itself, in the case of our first example, was fired off by an event called onLoad, which we briefly said was what happens whenever the page has finished loading. We'll talk about what that means a little bit more in this video and then further on in the series. But then we also were able to fire off or execute JavaScript code in response to a click event whenever the user clicks a button on our HTML page. We fired off a specific chunk of code that had a name, substitute. And you may have guessed that that substitute matched this substitute. It is defined as a function. It's a block of code that's executed together. This particular function has a name. The name is substitute. But in JavaScript, it's also popular to create functions that don't have names at all, particularly if they're only going to be used once. If a function has a name, then we can execute the code inside of that function as defined by these opening and closing curly braces. So all the code in here can be executed by merely calling the name of the function like we did here in response to the click event. Okay? So we're going to learn more about functions in lesson number 6. If you're coming from an object-oriented programming background like C# or Visual Basic, you know that classes are the heart of those programming languages. Well, in JavaScript, things are a little bit different. The function object is the focus, and understanding the flexibility of the function object and how it differs from other languages will ease your learning curve. Alright, so we started using functions at the very beginning. There are functions that are also built into JavaScript, or more correctly, they're built into the web browser's representation of the web page. This is called the document object model, and we're going to learn more about it in lesson 13. You'll be hearing a lot about it for the rest of your programming career, okay? But the document object model, or it's also called the DOM, D-O-M. And in particular, we used the alert built-in function. We also use this getElementById built-in function. And so the alert allowed us to display a message box to the screen. The getElementById allowed us to get a reference to one specific HTML element, in this case, the element that had the ID of my text box. And then we were able to retrieve its value. And notice there's this dot operator that's used in between several of these statements. It's a period on your keyboard. And we're going to talk about all of the operators that are used. The single equal sign, the triple equal sign, the opening and closing curly braces, they all have a purpose. They all have a significance in our applications. And we'll talk about what those are I believe 2 lessons from now, lesson number 4 or 5. We were paying attention to this getElementById function. It retrieved the value of what was typed into the text box that has the ID of my text box. And we saved that value into a variable. We defined a variable by using the var keyword. A variable, just think of it for now as a bucket in the computer's memory where you can store your stuff. You can save stuff that you need to reference later on. We saved the value that was typed in by the end user into the my text box form element. We saved into a variable with a name. The name was my value, and then I was able to reference my value throughout the remainder of our application. The same thing is true here. Here I wanted to get a reference to a specific element, the title element, which was our H1 tag, and we used that to change the HTML inside of it. So we replaced this with the value that was typed in by the user into our text box that I saved off in this variable called my value. So that's the relationship of all of those items. All right, the next line of code is interesting as well. We use an if statement to compare the two values. We compare the length of my value to see if it's equal to 0. And there are 2 different ways to compare or to check for equality. There's a double equal sign and a triple equal sign. We'll talk about the difference later. But at this point, we're using a property of our variable called length. And that allows us to see how many characters are in this variable. If somebody typed in the word Bob, the length would be 3. And therefore, this expression, when evaluated, would be false. 3 does not equal 0. When it's false, this block of code is completely ignored. When it's true, so when the user types absolutely nothing into the text box and the length is 0, then everything that's inside of these curly braces immediately following the if statement will be executed. We'll talk about if statements at length in an upcoming lesson. And then, as I already pointed out, we reference the title, again this H1 tag, by using the getElementById built-in function, referencing the ID of our H1. We save that reference, so we're saving a reference to the entire H1 so that we can check a property of our H1 and set its inner HTML and replace it with whatever was in the my value variable. Okay? All right, some more general observations. Now, all along while I was typing this, I encourage you to make sure that you typed in the code exactly the way that I did it. I probably should have emphasized that even a little bit more. As I pointed out earlier, programming is an exercise in preciseness. So everything matters. The periods, the parentheses, the quotes, the double quotes, the spaces, they all matter. The great news about most web browsers and the JavaScript compiler inside of those web browsers is that they are very forgiving. So, for example, depending on the web browser, you might leave off, for example, a semicolon at the very end. We'll talk about the purpose of the semicolon. But I might leave something off accidentally, and the page possibly could still work. Okay, it still worked. Now, that's not ideal, and the only reason it does work is because the JavaScript compiler was forgiving enough to overlook my little faux pas there, okay? The authors of web browsers have taken into account sloppy code, and there is plenty of it out there on the internet. However, as web developers, we need to strive to write our code correctly so that it offers a consistent experience regardless of which browser the user is currently running. So we can't always rely on a forgiving JavaScript compiler because earlier versions of web browsers may not be as forgiving, and a user encounters a problem that you didn't catch during development, and it ruins their experience. We'll talk about this more as we continue this video series. All right, also kind of alluded to this already with regards to all these special characters that we've been using, the parentheses, the open and closing curly braces, the equal signs, and so on. They are known as operators. They each have a purpose, they each have a meaning without them, or if you change the operator, the meaning of the code changes dramatically. Also, JavaScript has a few keywords, words that have important meanings. In this case, the word function, the word var, the word if, the word return. These are all reserved, or rather key words, and you can't use them, for example, as names of things. I can't use the word var as a name for my function without getting completely unreliable results. All right. And what's neat about JavaScript is that it's a very small language when you compare it against other programming languages. It has relatively few operators, it has relatively few keywords, but the language is powerful because of the ways that these operators and these constructs can be combined to do some remarkably complex things. And unfortunately, that's also the source of complexity in JavaScript once you get beyond the fundamentals. More about that a little bit later. Now, while I was typing out the JavaScript and I added that onload equals, and then later on when I was using the script tag here, you may have seen that little message that I popped up at the very bottom of the video that alluded to the fact that what we were doing here might be considered by most professional JavaScript developers as a big no-no. Well, in lesson 11, I'm going to right the wrong. But I'm going to continue to take this route because it's the easiest way to include JavaScript inside of your applications. There's a third way, that's actually the preferred way, but we're going to focus on that a little bit later about doing it the right way. So if you're an expert and you're about to write me a nasty note about showing people how to do things the wrong way, I acknowledge that. Please know that I do plan on discussing the separation of HTML purely for content, CSS purely for appearance, and JavaScript purely for behavior. And we'll talk about that more again later. All right, so after that we typed all of this code out and we attempted to run the application, our browser goes to work as it attempts to load up our HTML page into memory. It first attempts to acquire all of the external files like images or external cascading style sheets that we may have added or referenced within our HTML pages. It'll try to load up all the JavaScript files and make sense of it all. So to make sense of it all, it constructs an object model for your web page. This again is called the document object model, or the DOM. We referenced this earlier, and it'll give at some point during this effort of loading everything up, it gives JavaScript developers an opportunity to execute code. And this is why we were handling the load event in our very first example. We can write code that handles, or rather listens to, the load event. And then we can write code to respond to that event, to do things like changing things on the page, popping up alert boxes, and much more. And that's really the easiest way to write code, is to add an on-click event in the body tag. And there are the other ways like the script tag, and we'll talk about external references as well much later on. However, the only caveat is that the document object model may not yet be completely finished. So if we write JavaScript code that references some element on the web page, it may not yet be available in the document object model. That's quite a pickle, but fortunately I have a really simple solution to this problem. I'll explain more about that in like lesson 15 or 16 when we talk about events at length. Unfortunately, we're going to have to keep our JavaScript pretty simple until we get to that point. Alright, so at some point you'll recall that I changed the name of the call to our substitute method by removing the E, just enough to break our application. And I wanted to do that to demonstrate what can go wrong if you don't precisely spell a given word that you've already created. For example, the name of our function, or you declare a value here but you call it by another name later on. And so let's talk about errors that can happen in your web pages. Depending on the error, your web application may not work at all, or it may break at some point during its execution. Your user might get a message pop up on screen. It might be visible in a footer bar, or it might be hidden from them completely, like we saw just a moment ago when we were running this application in a broken state. Browsers sometimes hide exceptions because there are so many poorly coded applications on the internet. It would be burdensome as an end user to navigate the internet and see message after error message after error message. So the burden has been shifted to the web developer to make sure that their code has no errors. And there are basically two different types of errors that can happen in your JavaScript. There are syntax errors. These are things like forgetting a closing quotation mark, or a closing single quote, or a closing parenthesis, or not using a semicolon at the end of the line of code. Somehow the code is improperly formed. Then there are runtime exceptions, and these pop up because of an undefined variable, like we have here, an undefined function name. We never created a function with the name substitute without the E. In this case, we attempted to call a non-existent function. Runtime exceptions also occur when something outside of the developer's control happens. So a good example is that you're going to use a technology called AJAX to make a call back to a web server. Now, AJAX is a technology that allows a web client, a web browser, to contact the web server to retrieve tiny bits of information instead of loading a full web page every time something on the web page needs to change. We'll talk about AJAX much later in this series of videos, but let's say, for example, the web server is having problems today, and it happens to mangle the response back to the web page. Well, you, the front-end web developer, you have to account for this possibility. Fortunately, most of these things have been thought out for you, and so we're going to talk about situations like these near the end of this video series and how you can kind of ensure and insulate your code against potential problems like that. Okay, but here's my general advice when it comes to syntax errors and runtime exceptions. If you're testing your code prior to putting your web pages out on the internet, or if you're building a WinRT application, your end user should never encounter a syntax error or a runtime exception due to something that you could have prevented, period. There's no exceptions to that rule. The burden is on you to test your application in many different web browsers in different environments. But again, there are things that are outside of your control as a JavaScript programmer, such as that external resource, like a web server we talked about a moment ago. If it's down or if it's having problems that you can't control, well, then you need to insulate your application against that. You should guard against that possibility, and we'll outline some ways that you can do that a little bit later. All right. Now, the big question in my mind before we close this video is, does this code validate? We didn't check that. I'm going to select everything by hitting Control A on my keyboard and then copying our web page, opening up a web browser. Let's go ahead and shut this down. And then let's go to the text field and let's paste in all of our code. And let's click Validate. And we can see that the document is valid HTML5. All right, awesome. So we're kind of taking a challenging route in this series of videos. We're only using Notepad and Internet Explorer as well as the F12 tools to kind of create our applications. And that's fine. We want to keep this simple. We don't want to demonstrate a bunch of functionality and make you think that you have to use a particular tool to write these applications. You don't need a tool to build web-based applications, even with JavaScript. However, having said that, using a tool like free tools from Microsoft, like Visual Studio Express Edition, the Visual Web Developer Express Edition tool, again, free from Microsoft, can help speed your development time, and I'm going to demonstrate some ways in which it'll do that in the next video. So make sure you watch that, and then we'll be back to using Notepad for the remainder of this video series. Okay, so we'll see you in the next video. Thank you.